Algebra 2, Section 10.3, Solving Rational Equations. In Chapter 10, Section 3 has to do with solving rational equations, and the essential question, what methods are there for solving rational equations? And we're going to examine two of those methods today, the first one of which is one that applies for many more, practically any type of equation I can think of. We can solve graphically. And then we go to the second method we're going to talk about is algebraically. And in algebraically is going to be through the manipulation of symbols using algebraic techniques to isolate our unknown. And that's going to be more specific to this type of problem. Okay, let's go to explore, solve rational equations graphically. It talks about a rational equation that contains one or more rational expressions. And then we see solve the rational equation x over x minus 3 equals 2 by graphing. First identify any excluded values. An excluded value is what x cannot be because we cannot divide by 0 in math or in algebra. So we take our denominator and set that denominator equal to 0, but the way I like to do it, I like to say rather, in this case x minus 3 cannot equal 0, because that more completely explains what's going on. So if we say x plus 3 cannot equal 0, then if we add 3 to both sides of this equation, we have x cannot equal 3. And so 3 becomes our excluded value. So 3 is an excluded value of the rational equation. Rewrite the equation with 0 on one side. So if we take this equation x over x minus 3 equals 2 and subtract from it 2 from each side, we're going to be left with x over x minus 3 minus 2 is equal to 0. And then C, graph the left side of the equation as a function. Substitute y for 0 and complete the table below. So what we have left, if we substitute y for 0, we have y is equal to x over x minus 3 minus 2. And then we're going to fill out the values in this table by substituting in each input value. So if we substitute in for this equation here, 0, we get 0 over x minus 3 minus 2, so we get y equals negative 2, which leads to the coordinate pair 0 comma negative 2. If we plug in 1, I'm going to do this over here to the right, we have 1 over 1 minus 3 minus 2. What we get for that is 1 over 1 minus 3. 1 minus 3 is going to be negative 2. So we will get negative 1/2 minus 2, or negative 5 over 2, which in decimalized form is going to be negative 2.5. So we're going to have the point 1 comma negative 2.5. Next, if we substitute in 2 for x, we have 2 over 2 minus 3 minus 2, and in the denominator 2 minus 3 is going to be negative 1, and 2 over negative 1 is negative 2 minus 2 is going to be negative 4. So negative 4 as an output value, so now you have the coordinate pair 2 comma negative 4. Next, if we plug in 4 for x, we have 4 over 4 minus 3 minus 2, and in the denominator 4 minus 3 is 1, and 4 over 1 is 4 minus 2 is 2. So we have the coordinate pair here 4 comma 2. Next, if we substitute in 5, we have 5 over 5 minus 3 minus 2. And what we have is 5 minus 3 in the denominator is 2. So we have 5 halves, or 2.5 minus 2 is going to be 1 half, or 0.5. So here we have the coordinate pair 5, comma 0.5. And the last one we have here is 9. So if we take an input value of 9, 9 over 9 minus 3 minus 2. And in the denominator, 9 minus 3 is 6. And 9 over 6 is 3 over 2. And 3 over 2 minus 2 is negative 1 half. Or in the table I'm going to put negative 0.5. So our coordinate pair here is 9, comma, negative 0.5. Now we're going to plot the points here on the coordinate grid to the right. So we have the first one here, 0, negative 2, right on the y-axis. 1, negative 2.5, about right here. All these grid lines are by 2. And next we have 2, negative 4, which will go right here. And then we have 4, 2, so we go right 4 up 2. Then we have 5 to the right and 0.5, so that's going to go right here, just above the x-axis. And finally we have 9, negative 0.5 right here. And then at x equals 3, I'm going to draw a vertical dashed line, which is going to represent graphically a vertical asymptote, x equals 3. And so on the left side of the vertical asymptote, the graph is going to look something like this. Approach the vertical asymptote. And on the right side, we have this right here, and we cross the x-axis and go over to 9 and on. And so what we have, E, identify any x-intercepts of the graph. There is an x-intercept at, looks like 2, 4, 6. At x equals 6, and sometimes you can write this instead as a coordinate pair, rather 6, comma 0. And then F, is the value of x an excluded value? Is 6 an excluded value? No, the excluded value is 3. So what is the solution of x over x minus 3 equals 2? Well, solution, we will say, is going to be x equals 6. So this is how we solve by graphing. And earlier I entered this function in the calculator and graphing. Hope you can see that it looks like we have a vertical asymptote at x equals 3. And then over here to the right, 1, 2, 3, 4, 5, 6. The graph appears to touch or cross the x-axis, and we can verify using the table view. And down here at x equals 6, we can see we have an output value of 0, corroborating our answer here. Discussion: why does rewriting a rational equation with 0 on one side help with solving the equation? Well, I would say that what we have to do is, that means we just have to look along the x-axis for the answer. So that would be my short answer. And then we would see there the x-intercept, the root or 0, and be able to find our answer. Now the next section we're going to here is identifying the LCD, or least common denominator, of two rational expressions. And this skill here is prerequisite to solving these rational equations algebraically. So that's why we're going to do this now. And then we're given the two steps to find the LCD, or least common denominator. We need to factor each denominator completely and write any repeated factor as powers. And we use the different factors. And if the denominators have common factors, use the highest power of each common factor. And so we're given a couple examples here. Example A, where we factor each of these, and what I want to do is I want to go over B. We have negative 14 over x squared minus 11x plus 14, and 9 over x squared minus 6x plus 9. And to factor each of these denominators, for x squared minus 11x plus 24, we're going to have x and x. And then what we have, minus, or negatives are middle terms, so we're going to have minus minus. And then what two numbers multiplied together are 24, but added together are 11? Well, they're going to be 8 and 3. And then for x squared minus 6x plus 9, we're going to have x minus 3 times x minus 3. And list the different factors. We're going to have x minus 8 and x minus 3. And it says taking the highest power of x minus 3, well, that's going to be quantity x minus 3 squared. So what we're going to have here is, for our least common denominator, means we're going to have quantity x minus 8 times quantity x minus 3 squared, meaning that if we multiply each expression by this least common denominator, we're going to clear out our denominator and be able to go on and solve the equation. Your turn. Find the LCD for each set of rational expressions. So on the left here, we have 8x minus 24, and factored out, we have the common factor of 8 times quantity x minus 3. And secondly, we have our second denominator is 10x minus 30, and that's going to be equal to 10 times quantity x minus 3. Now for our least common denominator, we are going to have x minus 3 in common to both of those denominators. So x minus 3 is definitely part of it. And also between 8 and 10, 8 is not included within the 10, so we have to multiply 8 by 10 to get 80. So 80 times quantity x minus 3 is our least common denominator for problem 3. Now next, problem 4, I invite the viewer to find the least common denominator, and you can go ahead and pause the video here and play ahead to see if you got it right. Okay, for 15x plus 60, we're going to factor completely, and the common factor here is 15. So you have 15 times quantity x plus 4. And then for the second denominator, we have x squared plus 9x plus 20. And we ask the question, what two numbers do we multiply together to get 20 but add together to get 4? So we have x and x, and we have all pluses, so we're going to have x plus x plus. Well, the two numbers are going to be 4 and 5. So for problem 4, our least common denominator is going to be 15, because 15 shows up in the first denominator but not the second. And then we have x plus 4 in common, or quantity x plus 4. And finally, we need to include x plus 5 to pick up the denominator and the second denominator, so that's going to be our least common denominator. Now next, explain 2, solving rational equations algebraically. And we're going to go over a couple examples here, and they go over these in the book examples, example 2, A and B. And I'm going to go ahead and work out these examples because I want to explain them the way I want to explain them. So we're going to solve this algebraically, and the first thing we're going to do is find our least common denominator. But even before that, we're going to factor each denominator completely. Well, x minus 5, our first denominator, needs no factoring. Our second denominator, 2 times quantity, let me go ahead, 2x minus 10. Our greatest common factor here is going to be 2. So we're going to have 2 times quantity x minus 5. So our least common denominator between these two denominators is going to be 2 times quantity x minus 5. And we're going to use this least common denominator to avail ourselves of the technique of clearing the denominator. So I call this our least common denominator is going to clear the denominator, and what that's going to enable us to do is solve the equation a lot easier. So here I'm going to rewrite 3x plus 7 over x minus 5, and we're going to multiply each of these expressions on either side of the equal sign by the least common denominator, which in this case is 2 times quantity x minus 5. And we're going to do the same thing on the right side. So we have 5x plus 17 over, now we have 2x minus 10, but I'm going to write this in factored form. We factored our 2 times quantity x minus 5. And I'm going to multiply this expression on the right by the least common denominator, which is 2 times quantity x minus 5. And now we're going to cancel out, but even before that, we're going to locate the excluded values, what x cannot be. Well, since we cannot divide by 0, x minus 5 cannot equal 0. So x cannot equal 5. So we call this an excluded value. So that is our excluded value, x cannot equal 5. Okay, going on here, what we have is we cancel out what we can on either side of the equal sign. So if we do our least common denominator right, we should cancel out everything in the denominator. So we have x minus 5 cancels out x minus 5. And on the right side, we have 2x minus 5 over 2x minus 5. We have canceled completely what we have here. So what we have left is 2 times quantity 3x plus 7. And on the right side, we have 5x plus 17. And so going ahead and distributing, on the left we have 6x plus 14 is equal to 5x plus 17. And so solving for x, if we go ahead and subtract 5x, we get x plus 14 is equal to 17. And now subtracting 14, we have x is equal to 3. And the last thing we do is check to see if this x equals 3 is an excluded value. No, not excluded value. So we call this x equals 3 a solution, or sometimes you'll hear it called a real solution. Okay, so that is our solution to this problem here. Now we're going to look at the next example problem. It has a little layer of complexity to it here. We have 2x minus 9 over x minus 7 plus x over 2 equals 5 over x minus 7. Well, here we're going to have our least common denominator is going to be a little easier to spot, because in all these denominators 2 only appears in this second expression, and then we have x minus 7. And so this brings us to our excluded value. Our excluded value is x cannot equal 7, because x minus 7 cannot equal 0, because we can't divide by 0. So now we're going to apply our least common denominator to each expression in this equation. So we're going to rewrite this as 2x minus 9 over x minus 7, and we're going to multiply this numerator by the least common denominator, which is 2 times quantity x minus 7, and then we have plus x over 2, and we're going to multiply this by our least common denominator, which is 2 times quantity x minus 7, and then we have equals 5 over x minus 7, and we're going to likewise multiply this by our least common denominator, and now we're going to cancel where we can. So we're going to have on the left one we have x minus 7 over x minus 7 cancel. On the next one we have 2 over 2 will cancel, and then we have on the right one we have x minus 7 over x minus 7. So we have 2, we're left with 2 times quantity 2x minus 9 plus x times quantity x minus 7, and that's going to be equal to 5 times 2 on the right, so I'll just put 10 right here. And then we're going to distribute on the left, so we get 4x minus 18, distributing the 2 here, plus x squared minus 7x is equal to 10. And combining like terms on the left side, we have x squared, and negative 7x plus 4x is going to be minus 3x, and we're going to have minus 18 is equal to 10. And solving for 0 on the right, subtracting 10 from both sides of the equation, we're going to have x squared minus 3x minus 28 is equal to 0. And factoring this quadratic trinomial, we're going to have x and x. So we're looking for, we have minus 28, so we're going to have a plus and a minus. And we're looking for two numbers that multiply together to be 28, but have a difference of 3. Well, 7 and 4. And we have minus 3x, so the bigger number is negative, so we're going to have x minus 7, x plus 4. So using the zero factor property, let me go up here and work down here. And so we're going to have x plus 4 cannot equal 0. And so therefore x, I got that wrong. Actually, it's equals. We're not talking about excluded values now. Equals 0. X is going to be equal to -4. And also we have x minus 7 is equal to 0. So therefore x is equal to 7. Okay, now for x equals 7, since x equals 7 is an excluded value, what we do is we say x equals 7 is what we call an extraneous solution. I'll just call it extraneous. And an extraneous solution is a non-solution that is created in the process of solving an equation. And it comes up for certain types of equations. But x equals -4 is not an excluded value, so x equals -4, we call this a real solution. To this equation. So now you're introduced to extraneous solutions and real solutions. You can have more than one solution. Okay, the last thing we're going to do is we go to your turn, solve each rational equation algebraically. So I leave it to the viewer to go ahead and try to pause and solve this equation, and then play the video later, see if you got it right. Okay, so we have 8 over x plus 3 equals x plus 1 over x plus 6. In this case, our least common denominator, we're going to find we don't need to factor either expression on either side of the equation. So our least common denominator is going to be quantity x plus 3 times quantity x plus 6. And so let's go ahead and work this out. So and that's what we talk about excluded values. Excluded values we're going to have, since x plus 3 cannot equal 0, x cannot equal -3, and since x plus 6 cannot equal 0, x cannot equal -6. So let's go ahead and work out this problem. We have 8 over x plus 3, and we're going to multiply this by our least common denominator of quantity x plus 3 times quantity x plus 6. And on the right side of the equation, we have x plus 1 over x plus 6, and we multiply by the least common denominator, which is quantity x plus 3 times quantity x plus 6. And if we've applied the least common denominator properly, we're going to be able to cancel out everything that is in the denominator and have an easier equation by far to solve. So on the left side we have x plus 3 over x plus 3 cancel each other, and the right side we have x plus 6 over x plus 6 cancel each other, and left we have 8 times quantity x plus 6, and on the right side of the equation we have quantity x plus 3 times quantity x plus 1. I wrote them in a different order. That's okay. And so on the left side, distributing, we have 8x plus 48. And the right side, we're going to have x times x is x squared. And we're going to have 3x plus 1x, so that's going to be 4x. and then 1 times 3 is going to be 3. Now next we're going to clear out the left side to set that equal to 0, so we subtract 8x and subtract 48. We'll do these at the same time. Minus 8x minus 48, and we're left with 0 is equal to x squared. It's going to be x squared. Let's get this right. X squared minus 4x minus 45. And so we have 0 is equal to, we are going to factor this quadratic trinomial. We have x and x. So two numbers that multiply together equal 45 that are 4 apart. Well, those are going to be 9 and 4, or 9 and 5. So we have 9 and 5. And which one is going to be negative? Because they are 4 apart. Well, it's going to be minus 9 plus 5. That should do it. So what we have is, we have x minus 9 is equal to 0. And using the zero factor part, we have x plus 5 is equal to 0. So x is equal to 9, and x is equal to negative 5. And then the last thing we do is look to see if any of these answers here, solutions, are the excluded values. So no, they are not any of the excluded values. So we call these x equals, in set notation, negative 5, 9. These are real solutions. So this is all I have for you today in this video lesson. You're going to have the opportunity in section 10.3, I hope, to do other exercises to further develop your skill. I hope this has been helpful, and as always, thanks for viewing.